Good morning to everyone. It's Flemish here from Data Technology. Good to see some familiar faces. Delighted to welcome you all to our introduction to Qlik Data Integration. The majority of the people on the call here are long-standing Qlik users with very established, mature Qlik Sense and Qlik View environments. So it's fair to say that everyone has quite an intimate understanding of Qlik's analytics pedigree. But what we wanted to do today is to give our customers a clearer picture as to the other side of Qlik's business, and that is Qlik Data Integration. So it's a much newer addition to the Qlik portfolio, and it's one that I guess a lot of people still aren't that familiar with. So today I'm joined by Sunil Mistry from Qlik. For those of you who haven't met Sunil, Sunil is one of the sales directors in the Qlik Data Integration team at Qlik, who joined as part of the acquisition of Attunity 2 years ago. So Sunil has a really extensive data integration background, and he'll be taking us through the session today. And we're really grateful that Sunil has taken time out of his very busy schedule to join us today. Let's get started. Sunil, if you could switch to the first slide for me. Thank you. So one of the main reasons we wanted to have this session today is because over the years, as we've been engaging with our customers and engaging and speaking to organizations, it's fair to say that most of them have some sort of a cloud strategy. They're trying to modernize their data architectures. They want scalability and real-time transfer and agility. And there are three sort of architectural shifts that we're really commonly seeing. So firstly, we see a lot of organizations are complementing and replacing their traditional on-premise infrastructures with either a single cloud or multi-cloud service provider platforms. We also see a lot of customers moving away from traditional data warehouse environments and replacing them with modern, often cloud-based data warehouses and data lakes. And finally, a lot of organizations want to replace inefficient batch replication and ETL processes with real-time data streaming. So each of these shifts creates massive and high growth market opportunities, and these are all use cases that are supported by the Qlik Data Integration Platform. So that's really why we wanted to have this session today, and I'm going to hand over to Sunil now, who will explain what the Qlik Data Integration proposition is, outline some of the core use cases, and also take us through a short demo as well. So Sunil, let me hand over to you.
Great, thanks, Flem. So just following on from that then, so let me take you through how we address a lot of those challenges that Flem's outlined for you and the shift that we effectively see a lot of organizations going through. All right, so from an end-to-end platform perspective, what we're providing to complement the analytics is now a set of technologies that incorporate what we refer to as Qlik Data Integration. So Qlik Data Integration includes, as Flem mentioned, primarily the technologies that came with the acquisition of Attunity. So this was effectively products that allow you to replicate data in near real time from transactional sources and stream that data into new cloud targets or potentially even existing on-premise targets. So really what we're providing here is a capability to simplify the way you do ingestion of data. And then on building on top of that ingestion capability, we provide capability to allow you to do automation of new cloud data warehouse technologies. So the shift that we're seeing here really is that organizations that may have previously had data warehouses on premise are now looking to modernize those architectures and take advantage of new cloud data warehousing technology that exists in cloud like Snowflake, like Azure Synapse, like AWS Redshift and Google BigQuery. And those technologies provide a lot of scalability and agility to modernize how data warehouses can be built. But to complement that technology, you need a modern way of building those data warehouses and keeping them up to date with data. That's really where the automated approach comes in, right? Rather than using existing ETL methods, which have maybe been sufficient for on-premise technologies, are really not efficient and agile enough to kind of support the kind of use cases that organizations are trying to deliver in the cloud. So what we have here is a set of technologies that complement both streaming, and streaming can be streaming into other target databases, or it can also be streaming into data warehouses and data lake technology. And I'll drill into that in a little bit more detail on the next slide. And then finally, what we have as part of the integration suite to kind of really flesh out the capabilities is a catalog that will allow you to provide a single view into all of your data for governance, and also self-serve that data into your analytical layer. Now, one kind of key architectural point here is, although we integrate tightly with the existing Qlik Analytics portfolio, the data integration and cataloging capability is agnostic to the analytics platform. So from that perspective, regardless of whether you're using Qlik Sense or Qlik View, the data integration technology can be utilized to ingest data and build data warehousing technology, and complement other analytical solutions as well. So, for example, the catalog can provision data not only into Qlik Sense, it can also provision data into Power BI and Tableau. So really what we're providing here is a very open end-to-end platform that allows you to really kind of maximize the value that you can get from all of your data and deliver that into your chosen platform. Okay, so if we kind of just drill a little bit into the Qlik Data Integration Platform capabilities. So what we're doing is we're effectively using a concept called change data capture to pick up data from transactional source systems. So transactional source systems can be really any database or potentially application that is sitting on top of a database. So that's really where the core value comes from the Qlik Data Integration technology, is the ability to use change data capture to capture the change rather than query the source system. So this allows us to very efficiently take changes as they're committed to the underlying database and move those across and stream them in a near real-time fashion into the chosen target platform that you're interested in delivering data into. That platform, as I mentioned previously, can be streaming targets, and when we refer to kind of streaming targets, effectively we're offloading the queries from that source system and committing them into that target environment. So that could be into another database. So think of this as replicating data into another database. It can also be streaming that data into message-based architectures like Kafka. So we have many customers that are building applications in the cloud. So rather than analytics, they're building web applications, they're building stream processing architectures where effectively they're looking to take decisions on events in a real-time fashion, right? So in that type of scenario, we can take that same data and push that into an event-based architecture like Kafka. More traditionally, we can deliver that data into data warehouse or data lake type targets. So here you're looking at the standard cloud-based targets that we support. So I mentioned Snowflake, which is cloud agnostic. So Snowflake is available on Azure, AWS, and Google. But we then also support the native cloud-based data warehouses like Amazon Redshift, Azure Synapse, and Google BigQuery, in addition to just Oracle and SQL. So these can obviously be on-premise or in the cloud. Now, with the automation technology, this is really where we add a lot more value than just being able to move data, right? So the replicate technology that I'll demo in a second will show you how easily we can take this data and make that available into a target platform. The automation technology then will really accelerate your ability to deliver analytics-ready data in a data warehouse all the way through to a data mart. So we're generating all of the the ETL pipeline code that you would typically need to build yourself and automate that. And we see anything between 70 and 90% acceleration of delivering a data warehouse project by using this automated approach to building data warehouses and keeping those data warehouses fed with new data and refreshed incrementally. Finally, from a data lake perspective, we have similar capability to automate the delivery of data in a data lake, which is essentially a file-based architecture. So one of the key challenges that you have with a data lake is data lakes typically do not understand the concept of updates, although there is some innovation in this space where effectively data lake architectures and data warehouse architectures are coming together, but fundamentally data lakes are designed for use cases where you're effectively looking to deliver raw data which is stored in a file format, either Parquet or some other columnar file format. So what we do here is we stream that data into a set of files, but we automate the partitioning and the joining of those files so that you have an end data lake layer which is ready for analytics. So rather than having a set of files which then require a lot of additional processing, we deliver an end state in your data lake, which would be your kind of conformed layer of data that is then ready for analytics. Okay. All right, so just before I kind of move on to the demo, what I wanted to do was just give you a little bit of a slightly more detailed understanding of what we're doing when it comes to the data warehouse automation, because this is something which is relatively new. Many organizations for many years been using ETL tools to build out data warehouses and transform data and deliver that for analytics. And that approach is very well understood. But what we're now seeing is a shift away from ETL towards what we classify, or the industry refers to as ELT, extract, load, transform. So from a replication perspective, we're doing the extract and load, so moving data in a raw format traditionally and landing that data into your target environment. And then the next part of the process is where we do the transformation, and that transformation is delivered and pushed down to the target environment. So we're taking advantage of the compute that's available to us within the cloud architecture. And that's really how cloud architectures are designed to be more efficient by separating the storage layer from the compute layer. So historically, data warehouses have had tightly coupled compute and storage. So you typically would scale the storage and the compute together, and that's really the reason why on-premise data warehouses have not been as agile and typically a lot more expensive to scale with the increase in data volume, because you have to scale both the compute and the storage pretty much in line. In a cloud architecture, the storage is relatively cheap, so you can easily store very large volumes of data in cloud storage, and then independently scale up the compute layer to deal with different use cases. And that's really where an ELT architecture lends itself really well. So you're loading that data first, and with our technology, we make it very easy and efficient to move that data by just moving the changes and doing that in a real-time fashion into that storage layer. The second part of this would be how we can then build out that transformation where we're utilizing the compute layer within the cloud. So in a cloud data warehouse, this can be typically scaled up independently of the storage layer. So Snowflake do this, Redshift do this, all of the cloud vendors provide this capability of separation of storage and compute. So from a data warehouse perspective, what we're providing is now a set of capabilities that allow you to then automate that transformation layer. rather than using traditional ETL tools, which would be a bottleneck and kind of inefficient, we're taking the approach of using a model-driven approach. So the data model is really the first piece of the automation that needs to be put in place, and we can do this by automatically discovering the model. That model is then used to generate effectively all of the artifacts necessary to build your data warehouse tables. So we generate all of the DDL effectively to instantiate your data warehouse around a dimensional model, and that gets created for you. And we then additionally automatically generate all of the mappings as well to map the data that is arriving in the storage layer into your landing area of your data warehouse, and mapping that into your data model. So all of the mappings get generated, and you're then able to define your specific transformation logic that's specific to your business requirements within the tool. So that is then all pushed down into the data warehouse layer for processing. And we propagate that through all the way through to a final data mart layer, which would be your dimensional star schema for reporting purposes. So end to end, if we look at it as a platform, we're able to take the transactional data, move that into your data warehouse efficiently using change data capture. We're able to take that raw data and model that and build a data warehouse for you automatically based on that data model, so the physical tables, and generate all of the code that would be needed to load that data warehouse for the initial load, for the kind of the batch load for the initial set of data, and then incrementally refresh those tables with the new data as it arrives. And as I say, there's a lot of complexity in data warehousing that we handle. So, we handle the concept of history, so being able to, manage history within the data warehouse. Things like slowly changing dimensions, which some of you may have heard of, where you have to be able to kind of handle changes to dimensional data in your data warehouse. We handle that automatically for you, as well as the kind of the idea of handling late arriving dimensions. So a lot of the kind of complexity around data warehouses and temporal data, we take care of as part of the automation solution. Okay, so with that, what I'm going to do is now switch into the demo and just really show you the two key components of the QDI platform. So the replication technology, which is Qlik Replicate, and Compose, which is the data warehouse automation solution. What I'll do is start off with Replicate, and just to kind of orientate you a little bit around what you're seeing in front of you. So with Replicate, what you have is a relatively straightforward user interface that hides a lot of the complexity around what we're doing. So the idea with Replicate is that you have tasks, and tasks are moving data from a given source system. So here I'm highlighting a task where we have SQL as a source, and that is being delivered into an Azure Synapse target. So really, we can create these tasks very, very easily. And the first point that we need to kind of configure is the source and target that we're looking to connect to. So here we have the idea of endpoint connections. And as you can see in my demo environment here, I have a number of different endpoints that I've got configured. And within the solution, we support over 80 sources and targets. So creating a new endpoint connection is as easy as giving it a name and then just selecting the particular source system that you're interested in connecting to extract data. And if I just give you an idea of what we're doing here, if I just connect to Oracle, for example, all you need to really do is provide the connection string and some credentials in order to connect to that system. And then behind the scenes, what we're doing is, we're using something called a log reader to extract the data from the underlying database, right? So we're not querying the database, we're capturing changes using this concept of change data capture, which is taking changes from the log. And this is what we do for all the sources we support. And for each source, the way we do that, is dependent on the source. So for Oracle, what we're doing is we're actually using something called a redo log. In the case of SQL Server, it's the transaction log. With MySQL, it's a bin log. So all of these technologies have a mechanism for us to be able to capture changes typically, and we handle that for you without exposing all of that complexity to the end user. If I kind of just cancel out of this and show you what we have for Oracle, so I'm going to just show you a quick demo of an Oracle source. So here I'm just connecting to my Oracle demo system. You can see that connection's fine. So what I'll do now is just show you how we can create a new task. I'm just going to call this demo. And then from a replication perspective, we select the profile of what we're trying to do. And the solution supports a number of different ways of replicating data. So the most straightforward way and the most common way of replicating data would be unidirectionally. So we would capture changes from a source and deliver that into a target in a point-to-point fashion. Now, if you were replicating to another transactional database, so going SQL to Oracle or SQL to SQL, then it is also possible to do bidirectional replication, so we do support that. Logstream is the ability to support one-to-many scenarios. So in this case, what we would do is store the data and make that available for delivery into multiple targets. So we can read the data once from a source system and keep that data in a transient state on the replicate server for as long as necessary to deliver that data into multiple target systems. So this could be at different latencies. So you could effectively have, for example, 10 tables being replicated. Of those 10 tables, you could have 2 of them being pushed into Kafka in real time. You could have another 5 going into your data warehouse. And for that data warehouse, you could optimize it to deliver that data at a different latency. So it may be that for your data warehouse, you don't require that data, in seconds. You're happy with that data being delivered every 15 minutes. So you can configure that different latency to support different use cases, because there is obviously a cost associated, from the perspective of compute for that data being sent, right? So you can tune it accordingly to your business case. And then finally, something we've just really added this quarter is the ability now to also stream data using Replicate into Qlik SaaS. So here we would deliver data into the Qlik SaaS platform and make that available for refreshing QED layers within Qlik SaaS. So they're the different kind of options that we have from a profile perspective. And then we have the options around what you actually want to move, right? So initially, you would typically load the initial set of data. So, the full load is the existing data in the tables. And then after that full load has completed, we would synchronize all the ongoing changes. So we would apply those changes or store those changes. So what I'll do is for the demo, I'll do both. But essentially what this is doing is one, applying changes. So insert, updates, deletes get applied directly into the target. And store changes would create either change tables, or in the case of the data lake architecture, store the changes as a set of files. So that's the options that we have. And then really all I need to do is select the sources and targets that I'm interested in moving data from. So I can select my Oracle source here. And I'm going to push this data into SQL. So before I do that, I'm just going to quickly open up SQL as well, just so I can show you the data. But while that's happening, I'll just select the target. So I've got my SQL Server target here. So I'm replicating data from Oracle into SQL, if I click on the SQL one, I can also show you where that's going to be going. So this is my SQL Server target, and it's just going into this database called TargetDB. And I'll just test the connection to make sure that it's all working. Great. Right, I'm just going to click connect on that. You can see. Okay, so I've actually already got these tables in here. So what I'm going to do is, just in the interest of time, I'll just delete. Well, actually, no. What I'll do is I'll just create a new one. Call it demo topic. Okay. Right. So let's go back here. And what I'm going to do is change that. Cool. Okay, so I can now, select the data that I want to replicate. So I'm going to, in my Oracle source, it gives me all of the schemas that are available to me. So I'm going to just select this one called HR. So it gives me the tables that I want to replicate, and I can then effectively just select tables I'm interested in. I could have also dynamically done this. I could have actually given the task a set of table selection patterns, and that way, if new tables get added that match that criteria, they would automatically get picked up. From a replication perspective, any columns that get added or things like data types changing, they automatically get picked up. So we have this concept of automatically picking up schema changes and pushing those across. But that's really it, really straightforward. We can just select the tables. There are a set of kind of more advanced features that I won't go into today, but being able to kind of define global transformation rules or going into a particular table and selecting transformation or filter rules, that can all be done. But what I'm going to do in the interest of time is just kind of run this task. So I'll just hit run. You'll see that it's now doing that full load. So initially moving that data across. So that's happened really quickly because it's a small set of data. So you can see here the number of rows that have been moved, and that's all completed. And now it's sitting in this kind of change data capture mode, right? So the task is running, and it'll be just continuously run because it's sitting there waiting for changes to occur in Oracle, and those changes will then get picked up immediately and moved into my target system. So if I kind of come back to here and just show you this database that I created, you'll see that I have these tables now here. So for employees, you can see that we have some data. So these are the 25 rows. So sorry, 107 rows of data that got moved for the employee table. And we also have the change data capture kind of table, which is really kind of where we're storing the changes, because I selected not only apply, but store changes. So it will now also store changes in this separate table with additional metadata defining what the operator was and transaction ID and timestamps and things. So this is optional, but it's actually a really nice way to effectively just store changes in a set of change tables, which can then be used for audit purposes, or in the case of a data warehouse, refresh the data warehouse. And that's really how we do things with Compose in a data warehouse. We use this concept of change tables to incrementally refresh the data warehouse on an ongoing basis, rather than having to calculate what's changed within the database each time. So it's a much more efficient way of refreshing a data warehouse. So what I'm going to now do is just show you some data being replicated. So here I put a little utility that's going to just update the employee table. So you can see that I've increased the salary of the employee, and that's affected the 107 rows I had in that employee table. So that update's been picked up pretty much immediately and moved across and applied. And so if I now come back here and refresh the change table, you'll see that, just come back here and show you, just so you know what the value was previously. So the value was 2001. So if I come back here, you'll see that that has been applied to the table. So that's increased the value. That update's been applied, but also what I have in the CT table now is I have all of the changes recorded separately as well. So I've got both a before and after image of each of the rows representing the change. And we have all of that additional metadata around the timestamp, the transaction ID, operator. So that was the before image, and then after it was an update. So if it was an insert, you'd see an I here or a delete, etc. So all of this is, out of the box functionality that we provide to allow you to very easily pick up data and move that into different targets from a replication and ingest perspective. Okay, all right. So what I'm now going to do is just very quickly touch on compose. So this is the first part. So going back to that kind of ELT paradigm, this is the extract and the load of data. And typically that is a raw extract and load, because you want to make this as simple and typically not do lots of transformation as part of the ingest layer. Although, as I mentioned, there is the ability to do levels of transformation as part of the ingest. And typically that would be things like masking or some level of enrichment, maybe to make the data that you're moving more meaningful. So there are always kind of scenarios where you may want to do some kind of enrichment as part of the ingest, but typically you would do that transformation once the data has been loaded into the target and use the compute that's available to you in that target platform to do that more efficiently. So when we come to compose here, what we have here are different projects for building either data warehouses or data lakes. So here we have projects here which in the green are data warehouses, and the blue ones are where we're loading data into a data lake. So what I'm going to show you first of all is just a quick one for a data warehouse. So here we have our source data arriving into the data warehouse. The replicate is loading that data. So I've got my sources coming in. So here, if I click on this one, it's a CDC task that's doing the full load and changes. And it's really just, in this case, a MySQL database that's loading data into my landing zone of my data warehouse, which is SQL Server in this case. And I can just test the connection here. And then here is my actual data warehouse. So this is the warehouse that I'm going to build using Compose. And the warehouse schema is listed here. And then I've also got my data mart schema here. I can again just click on that. So really, from a Compose perspective, as I mentioned, it's a model-driven approach to building a data warehouse. So the first part is to create the model. And the way that we create the model is really twofold. We can either discover the model automatically, and that's typically how we start out on projects, is that you can just do a discover and use one of the source schemas to infer what the data warehouse model should be. So we can go back to the original source of the data that's arriving into the landing zone and use that to do that. And what we've got here is exactly that. So if I display this, we've discovered a data model based on the source system, and typically you would then modify this to kind of incorporate additional sources, add additional transformations or columns to the model as necessary. But getting the model right is really where the work is with Compose. So rather than spending your time writing lots of code and building mappings manually, the effort goes to kind of building this model, and that model then drives all of the automation for you. So here I've got the model. You can also kind of import a model. So, if you've got a data model in a modeling tool like Irwin, for example, that can be imported into the tool. So there's a few different ways of getting this model into the solution. But effectively, the model is a starting point. Once you have the model, you'll see that I can come into here and we have all of the tables logically. So if I click on, for example, order details here, you'll see that I've got the different relationships between the tables. We manage the history automatically for you, so that's just a configuration. So I can click on here and change that if I want to, for example, store history. And based on this logical model, we'll then generate the physical model. So this is a physical model we'll instantiate within your data warehouse. So just coming back here, just to show you very quickly, this is really the automation in action. So, we can, based on the model, create the warehouse for you. And then you'll see that what we're doing is we're generating all the mappings for you. So if I click on all the details here, you'll see that we've created all of these mappings automatically for you, and within these here you can see that there are some calculated transformations that were in the model. If I click on this, you'll see that it is just a very simple expression that we're calculating to work out the line item amount based on unit price and quantity, and then applying a discount. We can also kind of handle data quality and profiling as part of this. So, it's a full development environment to build out all of your logic, and then really once you're happy with all of this, we can then effectively run generate the code and run it. So if I generate the code, it will generate the actual ETL code, and I can show you this. So we're generating effectively SQL. And that SQL is what will get executed within the data warehouse. So once you've got your code, you can also then run it. I'll just run it pretty quickly. So that's loaded so that first table has now been loaded into my data warehouse. And then from there, I have my data mart as well. So I can then create my data mart, which would be my reporting layer from my data warehouse. Okay, so I mean, I'll kind of pause there as we've got about 5 minutes for questions. But what I've really shown you here is an end-to-end demo in a few minutes, really, of how we can extract data very easily using the replicate technology. So near real-time replication of data. And then load that into a data warehouse, and then use the compose solution to very quickly build a data warehouse and load that data all the way through to a data mart.
Okay, thank you, Sunil. That was an amazing demo and covering a lot of content in a very short space of time. So I appreciate we couldn't go into as much detail as we'd like to, but hopefully that's given everyone a nice initiation into some of the capability of the Qlik Data Integration Platform.